All right. Hi, good afternoon, everyone. So today we are going to be going through a new topic, and this topic will be what we will be practicing in our next class. And at the end of this recording, you will be given some questions to practice on your own. So we're going to jump straight into it. And I hope you guys find it useful. And if you have any questions, you can always send me your concerns or questions directly via WhatsApp. All right. So today's topic is factorization. Now, factorization has 6 different versions of it. So it's 6 different types. Before we go into actually looking at the different types of factorization, we need to go into what factorization is. And even before we do so, there's something I would like us to recap, especially when it comes to opposites. So let's look right here. So as we see here, we have operations in mathematics, and because math is all about balance, there's usually the inverse of any process that you're doing. So as you know, when you add, the opposite of adding is subtraction. The opposite of multiplication is division. The opposite of squaring a number is square rooting that number. And so we're going to go straight into another process that we should be familiar with, which is distribution under the distributive law. So we have 2 examples here. One where we're going to be distributing 3, which is known as a constant, and A, which is known as a variable. So let's look at the first example, 1. We have 3 brackets, x plus y, close bracket. We should remember that brackets represent what process? The process of multiplying. Okay, we're having a small issue with the pen. So yes, as I was saying, we know distribution requires the use of multiplication. So here we have 3. So that means we're multiplying everything outside the bracket by everything that's inside the bracket. So we're multiplying 3 times x plus 3 times y. And as we know, 3 times x is 3x and 3 times y is 3y. Similarly, we have example 2, where we have A as our multiplying agent. So we're multiplying everything inside the bracket by A. So we have A times x plus A times y. And as we know, what's the rule when it comes to multiplying 2 variables? We simply group them. So A times x is the same thing as ax, and A times y is the same thing as ay. So just like addition and subtraction being opposite, multiplication and division being opposite, square and square rooting being opposite, the opposite of distributing is factorization. So that's the first thing you need to understand. Factorizing is the opposite of distribution. And the process of distribution is what? Multiplying. So therefore, the process of factorization, since it's opposite, would be division. So that's the first thing you guys need to make note of. I recommend that you have this in your book so that you know that factorization, I'm just going to write it here quickly. Factorization is the inverse, and we know inverse means what? The opposite. The inverse, and I'm just going to put opposite in brackets. The inverse to distribution. This is very important to remember because this concept is tested heavily in the exam in different versions. So now that we kind of understand, or we should have an understanding of what factorization involves, let's look at the different types. So let me just scroll back and scroll across. So as we were saying, today's session, we're going to focus on the first 2 types, which should be factorization through distribution and factorization through grouping. So make sure that in your book, you copied on this entire list. So as we continue to learn, we just check off the ones that we would have learned and the process in which we've learned them. So let's get into our first type, factorization through distribution. So this is the condition For you to use a distributive approach to factorizing, each term, let me just put the word term, each term must have something in common. Now that can be a constant, that can be a variable, or it can be a combination of the two. So let's look at our first example. We have here 3, open bracket, A plus B, close bracket. We should know that anytime we see this, we need to get rid of the bracket. So getting rid of the brackets involves multiplying. So here we are applying the distributive law. And once we do so, we get our answer, 3A plus 3B, because we know that this means 3 times A plus 3 times B. Now, let's look at the answer and let's go backwards. And that is what factorization is. So let's start off here with 3A plus 3B. Now, we need to identify, is there any common entity between these two terms? So the two terms we have here. The first term is 3A, the second term is 3B. So what is common between 3A and 3B? The 3. So that means that I can get rid of, or I could pull out that common entity by using what process? If when we distribute, we multiply, when we factorize, what we should do, we should divide. And you divide them by that common entity. And that common entity was identified as 3. So when we divide by 3, it's the same thing as pulling it out the bracket. And so what will we have left back? When I divide by 3, this will leave me back with 1. So I'm just going to end up with A. Plus, when I divide by 3, what's going to left back? B. So essentially, you realize that factorization takes us back to our bracket version of our equation. So let's take a next look at a few more examples and let's see if we get the hang of it. So let's look at example A, 6x plus 6y. Again, we want to factorize, right? So that means what are we doing? We are pulling out what is common between these two terms. And in this example, what is common? Let's underline it. 6 is common for both terms. So that means we're going to pull out 6. And remember, when I say pull out, what does that mean? We're dividing by 6. So when I pull out 6 from x, 6x, what is left back? Just x. Put back the addition sign. When you divide by 6, what? 6y by 6, what is left back? Y. So your answer is 6, open bracket, x plus y. Let's try another one, B. Let's try another example, but instead of using a constant, let's use a variable. So let's look at MA plus MB. Now here we have no coefficients, we have no constants. So we just have a combination of two variables, M and A, M and B. What is common between MA and MB? M, right? So that means that I can pull out M. And remember what we mean by pulling out. That means we're dividing by M. And when I pull out M, what is left back from MA? Just A. Plus, when I pull out M from MB, what is left back? Just B. So that's our answer. That's our factorized answer. And another thing, how can I check to make sure my answer is right? If I multiply out my brackets, I should end back up with the original expression. So let's try that. M times A, MA, plus M times B, MB. That is how you can check to see if your answer is correct. So that's something you guys need to make note of as well. So let's try one more example of this nature, and then we're going to go into some higher difficulty level questions. So let's try now. P, 3, P, M plus 3, P, N. When we look at this example, now we have to look at two things. We have to realize that we have two variables in the term and a coefficient. So we got to look at all of that. Both are positive, so we don't have to worry about pulling out the positivity. So let's write what's common here. Both terms have what? 3. Both of them have what? P, so we could pull out P. That's the only common term that both of them have. So remember distribution, you have to find a common entity in both terms. That's why I can pull out 3P, because 3P is in both terms. Remembering now, what do we do next? We write what we have left back in the bracket. So what we have left back in the bracket is what? M and N. And what is in between that? Plus. So we're going to end up with open brackets like we have here, M plus N. Okay, so I hope everybody's kind of getting the gist of it. Now we're going to move on to more increasing difficulty level questions. So let's go back to A. We're going to have 10x minus 10y. Again, this is a simple one. We know that here 10 is a common entity, so we pull 10 out. What we're left back with? We're left back with x minus y. So we're going to put x minus y, close bracket. Let's look at another example, B. 64, let me use a smaller number. Let's use 16. 16 a squared minus 8a. No, this is a tricky one now. Does 16 and 8 have any numbers in common? What is the lowest common factor of 8 and 16? I could pull out 8 from 16 and I could pull out 8 from itself, right or wrong. And if we remember, when we say pull out, what does that mean? We divide. So if I divide 16 by 8, because that's what I'm pulling out, and I'm dividing 8 by 8, are those two things common? Yes, so we put 8 outside the bracket. Now let's look at the variables. I have a squared. What should we remember about a squared? A squared means a times a. So that's 2 a's. But this one means just 1 a. How many a's can I pull out from both of them? I could pull out 1 a from here, and I could pull out 1 a from here. Keeping in mind, remember what we mean by pulling out, dividing. So if I divide out 1 a, if I take out 1 a from both of them, let's see what's going to happen. So 16 divided by 8 is what? What am I going to be left back with? 2. Because we had 2 a's and I pulled out 1, or I divided by 1, how much a's will be left back? 1 a is going to be left back. You put your subtraction sign. 8 divided by 8 is what? Is 1. We don't pull it out. And the truth is, we pull out the a as well. So that's how we would get 1 here as our common entity left back. Let's see if we get back the same answer. So you realize that we just literally pull out this whole entire thing. We literally pulled out all of 8a. And if you divide anything by itself, so 8a divided by 8a, 4 divided by 4 is what? 1. 10 divided by 10 is what? So 8a divided by 8a would just simply give me 1. And again, how do we back check our answer? We multiply it out to see if we get back the same thing. This is something you should practice now because it helps you to master the process and to always make sure your answer is correct. So let's go. You know 8a times 2a, because you know you multiply 8 times 2, which is what, 16. And then we know a times a. But you know what I'm going to do? I'm going to do it the long way. Let's do it the long way. So we know we have 8a times 2a minus 8a times 1. We just multiply out the bracket. So let's go now. 8 times 2 is 16. A times a is a squared. Put the subtraction sign. And anything times 1, you guys should know, is itself. Is that the original answer or the original expression? Yep, so we know we factorize correctly. Let's try another one. C, example C. Please ensure that you pause the video when necessary to copy down these examples. And what I also recommend is that at some point, you see if you can work it out yourself. So for example, I tried this question. Pause the video now. See if you could factorize it on your own first, and then play the video to see if you would have done it correctly. This is a great way to develop critical thinking and to develop your sense of algebra and problem solving. So let's take a look here. We have 25x minus 10. So both of them don't have the common variable. So our focus is simply going to be on our coefficient. So we need to find out what number is common between 25 and 10. The only number that comes into mind should be 5. That means I need to divide both numbers by 5. Dividing both numbers by 5 suggests what? 5 would be placed outside the bracket. Is there anything else in common here? Nope. So you open the bracket. When I open the bracket, I don't know why this is going on. When I open the bracket, what will be left back after dividing 25 by 5? 5. Did I trouble the x? No, so I write it back. You put the subtraction sign. And then 5 into 10 goes twice. Let's see if that would be the correct answer. 5 times 5 is 25. 5 times 5x is 25x minus 5 times 2 is 10. That's correct. We're going again. Next question, D. Keep in mind, pause the video, and then attempt the question on your own and see if you guys are understanding the concept before we even go to the answer. So let's try minus 49p squared plus 7p. Now, what is happening here? No, we got 3 elements to consider. Just like what we were doing before when we were multiplying. Remember, we paid attention to certain things? We paid attention to the signs. Do we have 2 positives, 2 negatives? Do we have a positive and a negative? The next thing we paid attention to was the coefficient. The next thing we paid attention to was the variable and the power of the variable. Is the same thing you have to look at when you are factorizing. So let's look at negative 49p squared plus 7p. First thing first, both of them have different signs, so the signs are not common. In any case, when the signs are not common, you just pull out a positive entity. Let's look at now the coefficient. Our coefficient in this example is 49 and 7. What number is common between 49 and 7? If you know square numbers, you would know that 7 times 7 is 49. So that means I can divide both numbers by 7. So let's see what's going to happen here. Outside of that, so we're going to put equal. So we pull out the 7. Let's look at the variable. How many p's can I get from both sides? This has 2 p's because we know p squared is p times p. And this one just has 1 p. How many p's can I get from both sides? I can only take 1 p from both sides. So I pull out that 1 p. So I put my bracket. After dividing by 7, what is going to be left? So negative 49 divided by 7 will give me negative 7. We should remember the integer rule. And then when we divide out by p for both sides, what is going to happen? How much p is going to be left back when I take it out from p squared? Just 1 p. Plus, what do you realize here? We are dividing a term by itself. So what we're going to put here? 1. Again, how do we back check this? We back check this by multiplying it out. So let's do that quickly. Ooh, I made a mistake here. Sorry. So let's take a look at it. 7 times. I don't know why this is happening. But apologies, guys. Small technical difficulty. As you know, it happens. So give me 1 quick minute to sort this out. Okay, I think we're back on track. All right, so let's get back to it. So we want to back check. So we know 7. So I'm going to use a different color to do our back checking. So we know if we multiply these two terms, we should get back our original answer. So 7p times negative 7p plus 7p times 1. Let's see what we get here. So we're going to end up with 7 times negative 7 is negative 49. P times p is p squared. And you put the plus. 7p times 1 is just 7p. So we got back our first answer. So we know that's correct. We're going to keep it moving. We're going to keep it moving. Let me come up here so that we can come across. All right, so let's try our next example. Let's try E. So this should be E. Okay, let's try E. So negative 4x squared minus 6x to the third power. So we have a lot of things going on here. Remember, what are we looking for? Things that are in common, right, for both terms. What do you realize here? Both terms are what? Both terms have what? The negative sign. So we could pull out the negative sign in this example. Now, what number is common between 4 and 6? Both these numbers are even, so we know that we can use 2 as our factorizing coefficient. So that means I could pull out 2. Now, let's look at what's going on here. We have 2 x's here and 3 x's here. What are the highest number of x's can you get from both sides? I can get 2 x's from both sides. So that's what we're going to factorize it. X squared. So let's look at what's going on here now. Keeping in mind, what did we pull out? We pull out the negative on both sides, so that's gone. We pulled out 2. So 4 divided by 2 give me 2. And I pulled out x squared on both sides. So when I pull out x squared on both sides, is there any more x's to pull out in the first term? No, because we pulled out all the x's that we had. So then this is the tricky part now. Because you pull out the negativity, what is going to be left back? A positivity. So that's how you're going to end up with plus. And I'm going to show you why just now. Let's look at the next term. When we divide 6 by 2, what do we end up with? 3. No, we had 3 x's and we pulled out 2. How many x's will be left back? 1. Let's see if we got the correct answer. So let's multiply out. We multiply this by this plus this by that. So let's try it. Let me use green so we can see better. So essentially, we're going to have negative 2x squared times 2 plus, you realize it's negative 2x squared again times 3x. So let's work on that. A negative and a positive is what? A negative. So that's the first thing we need to remember. So, and we know 2 times 2 is what? 4. There's no other variable to multiply by x squared, so we put it back. Are we going good so far? Looking our way. Go back to plus. Negative 2 times 3 is what? Negative 6. X squared times x, we know x by itself has a power of 1. So how much x's do we have in ours? 3 of them. The only thing that we need to address now is this what? Clash in signs. What happens when we have a addition? The way this thing is happening. What do we do when we have an addition and a subtraction sign? It becomes what? Subtraction. So our final answer will be negative 4x squared minus 6x cubed. So you see, all of this was just us checking back our answer. You don't need to do this when you feel confident and you feel like you pull out the right thing, but this is just a way to check. So it's important for me to teach you how to check to make sure your answer is correct. All right, so let's try F. F is something a lot more interesting and fun. So let's look at it. 5WX plus 10WY minus 15WZ. Again, what type of factorization we're going to use? We're going to use the distributive law. How will we know we could use the distributive law? Because all terms have something in common. And so far, what do you see in common? All the signs are not common because, for example, this is positive, but this is negative. So let's look at the coefficient. We got 5, 10, 15. What is common there? 5. So you know how we do it. We know we're going to put what? 5 outside. Now let's look at the variables. We got WX, WY, WZ. What is common between all terms? A W. So we take out the W. So that means we are dividing by 5W. We're dividing all of our terms by 5W. So let's see what we have left back when we do so. When I divide by 5W, what is left back? X plus, take out the W, take out the W, but 10 divided by 5 is what? 2. So we're going to end up with what? 2Y. So 5 into itself goes 1. 5 into 10 goes 2 times. So we end up with 2W. Then we got to subtract. Again, 5 into itself 1. 5 into 15 3 times. And then the W cancels the W. So what do we have left back? 3Z. And that's it. Again, let's do a back check, because this is also important for us to do. Let's back check it. We know this means what? 5W times X plus 5W times 2Y minus 5W times 3Z. So let's work it out. 5W times X simply 5WX plus 5W times 2Y, 5 times 2 is 10. X times Y is, give me 1 minute, guys. All right, guys, apologies for that pause. There was just a small issue I was having with the computer. So we're going to begin right into it. No. All right, so let's look at another example. So no, we're finishing the one that we were doing here. So let's look at that. So we know 5y times 2y is 10w y. We just join the two variables. So we have minus, and then we have 5w times 3z is just 15wz, which is our original equation. So essentially, that is all we need to understand when it comes to factorization. The major operation used here is division. And the condition that is required to use this specific type of factorization is that there must be a common entity for all terms. There must be one thing that all the terms have in common. So this is what we call factorizing using the distributive law. So we're going to scratch this out because I think that we would have, done some examples that allow you to understand the basics. So that's what we're going to do. We covered the first one. Now we're going to look at factorizing using grouping. And once we finish factorizing using grouping, we will be given some questions to practice on your own. So when you hear factorizing by grouping now, so this is where we're going to just add another page. And we're going to copy down our topic, factorization using grouping. All right, so here is the terminology, or here are the conditions for factorizing by grouping. First thing first, you must be given 4 terms, at least 4 terms, or at least an even number of terms. But the truth is, it's usually with 4 terms. So must be given in between here, must be given 4 algebraic terms. So that means something plus something plus something plus something, or you could use interchange between addition and subtraction. The next thing is 2, out of those 4 terms, not all 4 have something in common. And that's why we cannot use the distributive law, because each term don't have one thing in common. But usually what happens is there are 2 terms that share something in common. Hence the reason for us grouping. So that means that what you're required to do is group the 2 terms that share that thing in common. That share something in common. And then you factorize using the distributive law. So the truth is, the distributive law, the distributive factorization is in grouping, but the most important step is the grouping step. So the last step is factorize using distribution. So let's look at our example 1. If I give you px plus py plus qx plus qy, there's 2 ways we can handle it. So first thing first, how many terms do we have? We must identify how many terms we're given. So this is 1, this is 2, this is 3, this is 4. So that means that this expression already obeys our first condition. We must have 4 terms, and this one has 4 terms. The next thing is, do all the terms have something in common? So let me look at P. The first one got P, the second one got P, but the third and fourth one do not have P. Look at what's going on here though. This variable has X and this variable have X, but not all have X. Similarly, this has a Y, this has a Y, but not all have X. Not all has Y. So you guys would realize here, we are seeing that we can group based on what is familiar or similar. In the first two terms, what is similar here? P, right? So I could group these two. In the second two terms, what is similar? We see something similar. What's similar? Q. So this is how we do it now. We factorize each bracket separately. So let's look at it. What can I factor out here? I could factor out P. When I factor out P, what is left back? X plus Y. Everybody seeing that? I hope everybody's seeing it. Let's look at the next one now. So we put our plus. What is common here between QX and QY? Q. So what do we have left back when we pull out Q? We end up with X plus Y. But guess what's going on here? Do we have something else in common? Anybody seen anything else in common? Look at what is inside this bracket. Isn't it the same thing as this bracket here? Remember, factorizing is the process of pulling out things that are common. So what is common between these two terms here? This whole entire bracket. So when I pull out this whole entire bracket, X plus Y, what do we have left back? The thing is doing some weird thing again. So as I was saying, when we pull out what is common, what is end up left back? What is end up left back is the P and the plus Q. So guess what is done with that? We put it in a separate bracket, P plus Q. And that's how we do the distributive law. Not the distributive law, sorry. The grouping by factorization. Let's try another one. Let's try another one. And we're going to go through the steps again. So let's look at three A X plus 3AY Actually, let's not use 3AY. Let's use something else. Let's use 6AY plus BX plus 2BY. All right, step one. Can we factorize this using distribution? That's the first thing. You always go through the list in your mind. You start off with the first one. Can I do distribution here? No, because all of it don't have A, all of it don't have X, all of it don't have Y, and all of it don't have B. And all of them have a different coefficient. Here we have 3, 6, 1, and 2. So we can't use distribution. So that means we need to now move on to the next type of factorization, which is by grouping. Now, what are the conditions for grouping? We need 4 terms. So we have 4 terms. That's the first thing you check. 1, 2, 3, 4. We have 4 terms. Good. Now, what is the second condition for using? What is the second condition for using grouping? We need to have 2 terms. The first 2 terms, do they have something in common? Then the second 2 terms, do they have something in common? So let's see. If I group these 2, and then I group these 2, do they have something in common? So let's check it out. 3AX and 6AY. Let's look at the coefficients first, because remember, you got to pay attention to the signs, the coefficients, the variables, and the powers. So we got 3 and we got 6. What's common between 3 and 6? 3. I can pull out 3. All right. When I pull out 3, now I have to look at the variables. What is common between the variables? Okay, here's an A and here's an A, so that means I can pull out A. So now I just have to write what is left back. So when I divide by 3A, what is left back here? Just X. Plus, when I divide by 3A, 6 divided by 3 is what? 2. A gone, so what is left back? Y. I hope everybody's seeing that. Let's look at the next two terms. What is common here? Looking at the coefficients, one of them has 1 and one of them has 2. So they don't have nothing in common with the coefficient. So we move on to the variables. The variables here would be bx. The variables here would be by. What is common here? So b. And what type of b? Positive b. Again, let's look at what is left back. When I take out b from bx, what is left back? X. When I take out b from 2by, what do I have left back? 2y. What do you guys see now? X plus 2y, x plus 2y. So that means we have matching brackets. So because we have matching brackets, what do? We take it out. So we put x plus 2y. And what is left back, guys? When we take out x plus 2y, what do we have left back? We have left back our 3a plus b. And we put that in a separate bracket. So that's how we end up with 3a plus b. This is example 2. So we're going to look at 2 more examples, and that will be the end of our first session. And then I will give you guys some questions to look at, some questions to practice, and see if we could strengthen our understanding. So let's try one with some negative numbers now. Let's try one with a negative number or negative variable, because we've been doing all positive. And in class, we would look at some higher level difficulty questions. So this would be 3. So let's try this one. 2ax minus ay plus 2bx minus by. Again, can I use distributive? No, because there's nothing that is in common with all of the terms provided. So now we have to look at, can we use grouping? Remember, what's the first condition? Does it have 4 terms? Yes, we got 1, 2, 3, 4. So step 2 would be what? Group the first 2. Luckily for us, right, guys, the way these questions come, the first 2 already got something in common, the second 2 already got something in common. Sometimes they might scramble it, and you would have to scramble it back. And that's what we're going to look at in class on Monday. Examples where the 4 terms do have 2 groups that have something in common, but you have to rearrange it. Sorry. Okay, so let's look at this. So I'm just going to group these 2. Before I was forgetting to group the sign, I actually have to group the sign. So just take note of that, okay? So let's look at it. We have 2ax minus ay. Coefficients, nothing in common, signs, nothing in common. But if you look at the variables, we have ay and ax. So that means what's common here? Our a variable is common, so we're going to pull out a. When we pull out a, what is left back? When I pull out a, I end up with 2x minus, when I pull out a, what do I left back with? Y. Okay, let's look at the second bracket. Again, both of them have 2 different variables, so I'm just going to pull out the positive of both. Okay, so what is it we're going to look at? The variables. Both terms have b, so we're going to pull out b. When I pull out b, what do we have left back? Open bracket. We end up with 2x subtract minus y. Again, what do you realize is happening here? Matching bracket. And to be honest, that's how you know you're going right. You know you're going right when you reach this stage and you realize your 2 brackets are matching. So what we're going to do, take out the matching bracket, 2x minus y. And what are we going to do now with the things that are left back? We're going to put them in a bracket. So what do we have in the second bracket? We have our a plus b. So we have a plus b. And so that is our answer here. So for tomorrow's class, this is what we're going to be revising. So I'm going to stop here for today because this is the two major concepts that I want us to cover. So we looked at the two types of factorization, we looked at distribution, and we looked at grouping. Tomorrow's class, again, we're going to be practicing some questions. So please ensure that you guys copy down everything that was done today and prepare yourself for our class tomorrow. So that's it for today.